Hi, everyone. My name is Denis Ignatovich, and we have also Dr. Grant Passmore. We're from Imandra and wanted to update you quickly on a couple of exciting developments that we've been working on for quite a while, but are very exciting. The first thing we wanted to talk to you about is CodeLogician, which is this, think of it like a tool that can be used together with things like Claude, CLI, tool, Claude Code, etc. But it's a way to help the coding agent formalize its thought in mathematical logic, so it can really navigate the various edge cases, prove properties, etc. So really make sure it doesn't miss an edge case, and which ultimately can lead to production issues, so forth. So Claude and other tools are really exciting, and they accelerate the speed of development. But if you're not careful, you can end up in bad places. And we're very excited about this tool, and every time we use it, we'll share this with you in a second. Claude always says, yes, this was useful because it uncovered new edge cases, etc. So, Grant, do you want to just set up kind of conversation in terms of how does this compare? Like, what's now versus what is Code Logician and Imandra X? How do they fit in? How do they change the process of software development powered by AI?
Absolutely. So first of all, I would say what we're describing here is a paradigm that's now being known as neurosymbolic AI. And this is the combination of really two classically distinct, but now utterly complementary and interrelated worlds. And that is statistical AI, things like LLMs that are based on, neural networks that are learning from large corpora, trained over them, and are doing a form of inference that is not logical inference, but statistical inference, creating things that sound very good based upon training data, for example, but not actually reasoning in a logical sense. And that's now being married with the symbolic side. So this is the so-called good old-fashioned AI, automated logical reasoning that goes back really to the advent of AI and is built around using logical formalisms like first order logic or higher order logic and other logical calculi to reason in a completely precise way. So there's no ambiguity, there's no imprecision, and the results that you get out are logically derived with a complete logical audit trail. And classically, these were really two different worlds. And there was a large barrier to entry, I would say, in a practical sense for people coming into the symbolic side, because always you had this issue that you have to take your domain where you want to reason and you have to come up with a formalization of it. You have to find a way to express your maybe messy, real world constraints that are coming from law, they're coming from regulations, they're coming from physics. You have to figure out a way to express them in a precise mathematical formalism that then all of a sudden unlocks this ability to logically reason. The power has motivated, many of us to go into that world, but it required a lot of expertise. And some of the most exciting things now that we're seeing with CodeLogician and with neurosymbolic AI in general is that with the marriage of LLMs and their ability to have a fluid natural language interface and do this kind of statistical, flexible translation from informal to formal, when you take that together with the symbolic side, now we're in a sense realizing the dream that I think everyone's always had with AI when you think about it deeply. And that's being able to apply, superhuman logical reasoning at scale in a way that's precise, correct, auditable, but applying it to things that are messy, real world, and do not require upfront expertise on behalf of the user. So that's the big picture. And then the components here. So we've got a core automated reasoning engine that we've been building for many years, designed it to be industrial strength, mission critical, reliable for the hardest workloads, always available in the cloud, logical reasoning at scale. And that's what we call Imandra X. And we'll show in more details over this video and many more videos how you can use Imandra X. But you can think about it as a theorem prover, an interactive proof development environment that allows you to reason about complex systems and has a tremendous amount of automation to help you do that, to really guide the user. But every step of the way, the results are precise, and they're designed to be independently checkable. Now, that's the reasoning substrate, but how do you get real world things like, Python code or legal documents into a realm where Imandra X can be used to reason about them? And that's where CodeLogician comes in. And CodeLogician is a layer. It's both an agent and a toolkit that effectively allows you to take these informally specified domains, whether they're code or, legal documents, or maybe even something that comes out of a dialogue with an LLM, and translate the relevant logical features into a precise logical model so you can apply automated reasoning, in our case with Imandra X. And now, yeah, do you want to take it from there?
Sure. So the big idea, as Glenn mentioned, is we want to pair these two types of AI, statistical and logical, and want to do it not in a kind of theoretical sense, but actually something that can be very helpful to developers as they're using LLMs. They're shipping faster, and ultimately need to make sure that the code they're shipping is not just uh, let's say purely statistical in nature, but there is a logical reasoning that happens about it. So, in a practical sense, if you think about everything that, let's say, developer writes, let's just pick Python. There's a lot of code that you wouldn't make any sense to apply logical reasoning for. So there's a lot of boilerplate code, people developing TUIs or translation or generating HTML. A lot of this kind of more mechanical code that would fall outside of this. Where this really shines is the things where you need to consider payment systems. You need to consider edge cases, things that can go unnoticed by the LLM, again, due to statistical nature, and by the fact that you have lots of code that's being auto generated. And these things that will ultimately end up causing issue 2 o'clock in the morning and can be quite painful. This is where it shines. We're not saying you want to replace everything, but when you are designing these systems and you're asking LLM to generate a lot of code for you, you want to make sure that the things that are really sensitive, again, security, think about the various edge cases, state machines, transitions, how different services communicate with one another, all of those things, you want to make sure that LLM can logically describe them and make sure that it really understands all of these corner cases. It can verify mathematically that the design it's coming up and suggesting to you is correct. And so, as Graham mentioned, we have CodeLogician. And besides the demo that we'll show you, we have some exciting results where we've done a case study just kind of over a bunch of different examples of software that LLMs should be able to reason about. And so these results are available on archive paper. You can find a link at codelogician.dev. But the fundamental result that we demonstrate, even this is using Opus 4.6, which just came out in early February, we can demonstrate that you see, in many cases, over 50% performance improvement when you combine LLM with the reasoning engine, when it needs to understand these really critical things pertaining to control flow, edge case detection, coverage completeness, direction accuracy, so forth. So this is not a tool that is nice to have. In many cases, when you're writing this software, you really want to make sure that you have this logical component in the mix. Because, let's face it, really anyone that can type on a keyboard cannot wipe code. What separates really people that are professional at it are the ones that can actually have logical guarantees and logical artifacts produce, making sure that software is quality. So,
Exactly. And maybe some of the listeners here are familiar with the term formal verification. We haven't really stressed that, but that's really what's happening behind the scenes is that with CodeLogician, you start with a piece of code in your programming language of choice. Let's say it's Python. CodeLogician is actually working with the semantics of Python, working with LLMs, working with a number of both statistical and symbolic tools to then produce a formal model in a mantra of what that code does. And then actually help you, first of all, elicit your requirements, so the properties that you want to verify, and then use a mantra to analyze them. And there, you can get out proofs that your system satisfies the properties you care about. You can get out counterexamples. Those are extremely valuable because they often, especially if they're succinct and minimal, they often point you directly to serious flaws. And this whole process, right, formal verification of code, even in the pre-LLM world, this has been a critical component of safety critical industries like avionics, like, various aspects of defense, certainly in capital markets, which is where Imandra has done a lot of work. All of these are high stakes, highly regulated, mission critical, and in many cases, safety critical uh, environments where the code better be correct. And even before an AI system was writing the code, formal verification was important because when code reaches a level of logical complexity, it is just virtually impossible, even for a human who is extremely tuned into the domain, writing the code themselves, perhaps with a team of extremely well engineered control flow logic. It often is very difficult to get that code right. And that's why formal verification is required in these industries, hardware too, especially. So now, if you bring that to the modern day, where code is being increasingly developed by people who are not actually seeing any of the code in the programming language that's being targeted, they're often not even software engineers by trade, but they're, using these tools to do amazing new things, which is so liberating and democratizing and has so much power and excitement around it that can be doing very good things. But you then have to make sure that code actually meets its requirements. And so formal verification to go in and logically vet the code is necessary to an even higher degree.
Absolutely. Okay, to get started, it's quite easy. Go to imandra.ai, create an API key. It's free to start. Right now, we run CodeLogician with a Python 3.13 environment. So once you install it, just make sure that the Imandra unique key is in your profile, in your shell. Use Claude Code tool that developers can have access to make sure that they're using these tools like Claude and others with much more assurance and much more rigor.
So I wanted to advertise for anyone interested to you can go to Imandra.ai and you can go into the CodeLogician page here, or you could just click directly. I'll show you CodeLogician page just so you see it and read our new paper. That will take you to the paper and archive of Imandra CodeLogician, Neurosymbolic Reasoning for Precise Analysis of Software Logic. And here, one of the things I want to highlight is this is, as far as we know, the first really rigorous study of neurosymbolic improvements over just plain LLMs and many different LLMs for a wide variety of code reasoning tasks. And you'll see one of the things that we introduce here, besides the actual, CodeLogician agent and system itself, is we introduce a new benchmark called Code Logic Bench. And this is actually showing you a major feature of Imandra that's extremely powerful and used by coding agents all the time when they invoke CodeLogician. And that's something we call region decomposition for analyzing a state space, mapping out its behaviors. That's something we should do many videos on, but it's absolutely critical. CodeLogician makes that easy. But basically, as you go through the paper, you will see you get a description of how CodeLogician works, the architecture, CodeLogician server, which allows you to work on, large multi-file, industrial strength, multi-module softwares with complex dependencies. But you can then go into the actual Code Logic Bench. And here, yes, there's a lot here. But basically, Code Logic Bench is this new benchmark set that, it's open source and it's going to continue to grow. But the idea is that it's really addressing an evaluation limitation that hasn't been there in the other benchmarks like SWE Bench on how successful, how accurate is an LLM or coding agent at the real kinds of reasoning tasks that come up in actual code design, software design, engineering, and synthesis. And that's things like, evaluating effectively the correctness in enumerating unique behaviors of a state space. So that's called state space estimation accuracy. Outcome precision. So this is effectively looking at constraints and conditions in an LLM's answer and effectively evaluating correctness of those. Directional accuracy. So this is for answering questions effectively about system behaviors and the way a system can develop, especially a system that you think of as a state machine. Coverage completeness, control flow understanding. So, edge case detection. These are all critical components of reasoning about code that, of course, when you think about it deeply, okay, you have to, in general, have robust, rigorous logical reasoning involved. But of course, LLMs are trying, in a sense, to do this, or people are trying to get them to do this implicitly very often when designing systems and writing code. And this effectively is a way to measure progress in that domain. And overall, some of the biggest things that we see are, okay, if you do this on the latest and greatest LLMs, you get, let's say 60% performance across, one of these metrics. But if you have that same LLM and CodeLogician in the mix, you can get tremendous improvement and you get guarantees. And also for, many core operations, these things actually become much cheaper and more efficient to operate because, in a sense, we're pushing things that were being done through statistical inference. We're pushing them. These are very precise questions about the behavior of code. We can push them to a completely deterministic, precise reasoner that is optimized for that task. And, all of that is just many facets of this compelling reason for going neurosymbolic when you are creating code in any sort of mission critical environment. Okay. So now I just wanted to do a little CodeLogician magic on my machine. So we've got CodeLogician here. This is the TUI. And for example, we've got this help system that an LLM can navigate beautifully, but so can a human, and can learn about region decomposition. For example, could see if we had any decomps. There's none going right now. Set up configuration. But I am just going to have Claude use it as a tool. And what I've done with Claude is I have actually created a model here of the pricing logic of a trading venue. So this is of Six Swiss. This is one of the big trading venues in Europe. And as you can see, this trading guide, this is an older one, but this has 200 plus pages, very complex logic. And it's basically through these many examples teaching the user how this system works, what the different order types are, how they affect pricing and order matching. And, we could go through and see, for example, if the reference price is less than the remaining buy limit price, then a price of a trade of a match is a remaining buy limit. And we can see in this concrete scenario effectively what the price is. So this is a very complex algorithm that's being described, in a bunch of examples and prose, a bunch of tables. And this is pretty typical, in regulated industries like capital markets. You'll have spec documents like this. And, if you then want to actually develop a system that knows how to interact, your own software that knows how to interact with this or trade on it, well, it needs to properly understand the logic, how it works. So we can build a formal model of this. And we have an Imandra model now, and I want to ask Claude about it. And so, a fundamental question that I've had about Six Swiss is how many unique behaviors are there of this pricing logic? Because this was a lot of examples. And, Dennis, from your days trading, right? The complexity is in these different combinations where there's subtle behaviors of different order types that could be triggered by different parameters and different book states that really cause the system to behave in drastically different ways. Would you say?
Absolutely. This is quite often where you have to consider subtle edge cases and really in very safety critical systems that have to process lots of transactions. So any even small glitch could be very, very bad.
So we don't want to mess around here. And I want to have the latest and greatest AI coding agent help me understand it. Claude Code here knows about CodeLogician. So I'm going to tell it, don't use it first. And I'm going to say, without using Imandra CodeLogician, I want you to analyze the pricing logic of the Six Swiss exchange model in this directory and tell me how many unique behaviors there are. Okay, so let's have Claude Code Opus 4.6 work on this. reading the model file. Always curious to see what it says behind the scenes. User wants me to analyze the pricing logic without CodeLogician. Okay, that sounds good. So, Dennis, when you were trading, how often would you find a system with a state space that was wildly more complex than you expected?
I think all of them are fairly complex. And actually, part of, at least in Europe, part of the requirement to be able to trade, say, with an investment bank or any other firm, really, to have access to an exchange and perform other, say, tasks, you had to have certification from each major exchange. And that typically, so you had to pass an exam. And part of the reason for that is just to understand what the basic kind of market microstructure that was implemented, the various rules and regulations of the particular exchange. This is on top of the actually government license and certifications that have to be taken. This is kind of learning how all of these different complex systems operate. Is I would say it's you know at least half the job of being in trading in Europe.
So when you were getting licensed, let's say to trade on Six Swiss, you would actually have to study a document like this and understand the different nuances of the order types, for
Absolutely,
example. Yeah.
yes, and there was a test after that.
Well, look at this. Okay. So first of all, let's just note how long that took. I don't think, oh yeah, a minute and 40 seconds for it to study this logic. And this is already logic that is in, precise code. And it comes back analyzing the match price function, and it tells us effectively these different regions. And so let's first of all note, this looks to be far fewer different distinct regions than what is given in this document. So that's first of all, it's very interesting. But then let's see the total 38 unique behaviors. So it took a minute and 40 seconds, and it says there's 38. And that, it's enumerating definitely some unique behaviors, but let's get CodeLogician to analyze it precisely. So now I'm going to say, use Imandra CodeLogician now to precisely analyze the number of edge cases. And I'll just tell it use region decomposition. It would have done it probably automatically anyways. And now let's watch this process. Okay, let me run region decomposition on match price using CodeLogician. File already has decomp top at the end. So, okay, so it's got an annotation about decomposing it. And so that is something, oh, look at that. Already eval success decomp. Let's see what it's doing. Searching through memories. Interesting. And let me get a cleaner summary, et cetera, et cetera. So this core thing, I'll tell you what it did. This was precise logical reasoning about all of the edge cases. And that was done in, I think, basically a fraction of a second, as opposed to a minute and 40 seconds. Oh, parsing missed quote types. Let me extract more carefully. Okay, so Claude Code is iterating on effectively this precise output. Quote types aren't being detected, likely expressed as negations. Now I see quote is expressed, not limit, not market. So this is all Claude effectively interacting with the system and working with the output. We can all compress various aspects of this. But I like the fact now that we've seen region 43. Well, that's a lot more than 38. Look at this. Oh, now we see. Now I have the complete picture. Here are the results. Magician, match price has exactly 44 unique behavioral regions. Key takeaway versus my manual analysis. My early manual estimate was 38 regions. I undercounted the market case. CodeLogician found 16 regions there versus my estimate of 9. The difference comes from the secondary price discovery logic when both top orders are market. Let's see this window. I think it's not. Oops, this is a little smaller so we can read it. Secondary price discovery. Decomposition distinguishes every combination of how best bid and best ask are derived, since each path has different constraints when the output expression is the same. So, wow, you actually missed distinct regions of behavior with, let's say, subtle, nuanced outputs. Let's see what it has to say to that. While Claude is thinking about diagnosing its issues there, I will show, this is actually that Six Swiss model that it was reasoning about. And so it's a, model of an exchange. It's got order types. Order has a bunch of different, kinds of data associated with it. It's got ranking logic for when one order should be prioritized over another, has a state for the exchange. And what we're analyzing here is this pricing function. And now I'm going to decompose it and actually go visualize its behavior. So you can do this all with Imandra X, and we can effectively go and drill down into the unique behaviors. And this is now what Claude is able to do with Imandra's help. And we can see actually, oh, okay, let's go to this guy. This is a unique behavior where the reference price is used, and this is symbolic. So there, in general, can be infinitely many possible orders in a sense that fall into this region. But crucially, this has 44 regions as opposed to just 38, and those edge cases matter. So here's the result. It says, yes, exactly. The big miss that Claude had was in market. I found 9 regions. CodeLogician found 16. The difference comes down to something subtle that's easy to gloss over in manual analysis. When both top orders are market with equal quantity, et cetera, et cetera. So now it's able to understand what it missed and why, because it's using Imandra via CodeLogician to actually do this analysis. And this is just the foundational, utterly required component now for robust AI-assisted code development in any sort of regulated enterprise or high-stakes environment. I don't know if you want to add anything to that, Denis.
Ren, I was just going to say, how many lines of code is that?
Say about 300.
Okay, so that's about 300, and you can see it already detected fairly major issues there. So imagine you have 30,000 lines of code.
Exactly.
And you have not only, another thing about this is LLMs are kind of bad at reasoning across different domains and different microservices, how they interact, etc. So this is, if anything, we're really kind of testing it. It's the thing that it's strongest at is fairly small amount of code, but looking at kind of edge cases and understanding it there. So this is the thing it should be strongest at. And when really this approach even shines more is when you have many different components and it has to create a logical model of how they all interact. In those cases, the LLM would never be able to be able to analyze things.
Yeah, fundamentally, anybody doing AI-assisted coding, you have to have a symbolic component for any sort of mission-critical, regulated, high-stakes code. And the whole point of what we're doing with CodeLogician is to make that easy, effectively, immediately plug-inable into existing workflows, and to turn it into a tool that the LLM coding assistant actually uses on its own because it realizes it actually makes its outcome better.
Excellent. I think this concludes this video. So until next time, thank you.
Thanks, everybody. Cheers.